Let's go to full screen mode. Okay. Why is the bottom portion visible? First of all, extend a warm welcome to all of you for deciding to attend this workshop, at least the inaugural session. So you already know my name is Siddhartho. I'm a fourth year PhD student at the Discrete and Computational Geometry Lab of the Computer Science and Automation Department at IISc. So I work on, and I have already worked on the design and analysis of efficient algorithms and data structures for different computational geometry problems. So this is my supervisor, Professor Satish Govindarajan, who is also the faculty in charge of the Discrete and Computational Geometry Lab of CSA. And he is an expert in discrete geometry, which is also called combinatorial geometry and computational geometry. And without his active support and cooperation, this workshop wouldn't have been possible. So in addition to that, there are two other faculty members in our department who work in geometry. There's another dedicated geometry lab, which is called the Geometric Data Structures Lab, and which is headed by Professor Rahul Salade. So there's one more lab, which is headed by Professor Arindam Kha. And their lab is called Algorithms, Complexity and Optimization, but they have also worked on different flavors of geometric problems that you are going to see throughout this workshop. So to say, there's a fairly large group of people working in geometry. I mean, not only the faculty members, but also the lab members. So primarily, the goal of this workshop is to introduce you to the field of geometric algorithms. As you have seen in the website, the goal is humble. The goal is not to be enabling you to do research right away, but the goal is to give you an introduction. Okay, and my hope is that once you will go through the sessions, once you will attend the sessions, you will gain some confidence into starting your work in geometry if you have not done any work in geometry before, beyond high school geometry. And last but not the least, as I already said, that there is a fairly large number of people in our department working in various geometry problems. We have a lot of fun discussing geometry. And I would say that our strength, I mean, the number of people working in geometry is probably the largest in India, anywhere in India. So many people working in geometry in our department in IISc Bangalore. So my primary goal is giving you an introduction to geometric algorithms, but this is also a very important goal that if I can share that even partially, even some portion of the joy that we have felt to you, then I will be happy. So let's say we meet each other maybe after 6 months or 1 year, and you tell me that I do not remember anything that you have discussed in the workshop, but I had fun in the workshop, then I will consider my job done. Okay. So this is the agenda for the 5 days as a summary, which I think if you have looked at the website, you already know. In the first day, that is today, we are only going to give an introduction of 2 things. One is geometric algorithms and the other is approximation algorithms. So my target is to give you a bird's eye view of these 2 things. So geometric algorithms and approximation algorithms, these 2 are semester-long courses in themselves. So you can understand, like 2 semesters of content is compressed into 2 hours. So you can understand the level of compression. So you can realize that it is only going to give a bird's eye view, but this session will enable you to sort of understand the problems that we'll discuss going forward. We look at some nice geometric problems, which we say are basic in nature, and these are going to be the stepping stones for you to attend the subsequent sessions. Okay. On the 3rd day, we'll discuss something called visibility problems. So just to give you a flavor, one classic visibility problem is the art gallery problem, in which you are the owner of an art gallery. So you have different monuments and different arts displayed on the walls of the art gallery. And you can think of the art gallery as a polygon, and you want to place guards or nowadays CCTV cameras such that all the walls are visible. So for every portion of the wall, there is at least one camera that can see it, that can focus on it. Okay. So you want to minimize the number of cameras or number of guards. That is the classic art gallery problem. So there are many variants of visibility problems. So we will see one or two nice examples on the third day. On the fourth day, we will see some covering problems. So now by day 1, day 2, day 3, you will have the foundations to understand what these problems are. So with time, the pace and the complexity of the problems will increase. So there are many different kinds of covering problems. One of them, which has wide use in wireless networks, is that consider a city. And suppose you are a telecom service provider and you want to provide service throughout the city. And you have certain constraints where you can put your base stations or antennas, which will sort of provide coverage to the people of the city. And understand that the coverage of an antenna is only some couple of kilometers, maybe, or maybe there is a radius along which a particular base station can provide coverage. So as the distance of the receiver from the base station increases, the coverage quality will decrease, right? So one pertinent question is to ask that how I will put my antennas so that everybody will get coverage and my cost will be minimized. So that is one classic example of covering problems that has practical applications. Okay. So now on the fourth day, we're going to talk about packing problems. So you might have seen that I have categorized the days as 3 parts, like basic problems, intermediate problems, and advanced problems. So you can think of packing problems as advanced problems. So packing in itself, like there are tons of books on packing. So it is itself a branch of computational geometry. So there's a lot of papers on bin packing, there's a lot of things. So think of it this way. Suppose you're Amazon or you are some transport service provider, and you have to transport some goods from your warehouse to several locations throughout the country. And these goods come in different shapes and sizes. There are different packagings. So you would like to optimize a lot of things. First is you would like to minimize the number of vehicles that you need to assign so that all these objects, all these items can be transported to their respective locations. You also want to minimize the distance that you have to travel so that you can save on your fuel cost. So packing, the packing problem, one of the classic examples is that you have a vehicle and there are so many items to pack. So how you can pack the maximum number or maximum value items into the box or into the vehicle. So this is just one simple example. There are many examples where packing will come in real life. And on 5th day, we'll look at one particular example, which is sort of the holy grail of computational geometry. It's a very hard problem. But understanding these questions will sort of give you an idea of what kind of problems people work on in geometry. I mean, beyond high school geometry, right? So is there any question so far on the agenda?
No.
So, right.
I'm assuming each session will be around 2 hours, right?
So yeah, that's a good question. So the session starts at 5. So 5 to 5:15 is the time when we will discuss what we have already discussed, or if there are doubts, we can take the doubts and we can discuss among ourselves. And then there are 2 talks. Every talk is 1 hour in length. So between two talks, there should be a break. Like I don't think that people have the patience to listen for more than 1 hour. So after the first 1 hour long talk, there will be a break of about 10 to 15 minutes, and then we'll have the second talk. And then we'll have sufficient time. There is some specific time that we have allotted for discussions, Q&A, and like brainstorming. So overall, it's 3 hours. But if you don't have questions, you don't want to take part in discussions, which I will not encourage, then you can leave after the second talk as well.
Okay,
Does that
thanks.
answer your question? All right.
Yes, it is.
Fine. So for this 5-day long wonderful journey into computation geometry, I have 2 tips for you. That you interrupt me when you don't follow me. So I have been in this field for quite a long time. So I may not go at a pace in which you can follow. In that case, you have to put your hands up. You have to show me the red flag, and you just unmute yourself and let me know that I'm going too fast or you didn't understand the particular point that I'm making. Okay. You ask questions. There is no reason for me to discourage questions. In fact, I'll give you an anecdote. So I grew up in a small town in Assam called Bongaigaon. And when I was in school, there was a professor. So he made one statement while addressing a set of students. And that statement has stayed with me for, let us say, more than 15 years. So he said the following. He said that the wealth of a person he measures not by the amount of money he has in his bank account, but by the number of questions he has in his mind. So that is how sort of motivated he encouraged curiosity. So I would sort of encourage you to ask questions as much as possible. Whenever you are in doubt, please feel free to ask questions. There are no stupid questions. I will never judge you. Okay, so this is myself. If you have any questions, any doubts, anything, feel free to write an email to me. This is my email ID, siddhartha.s1@iisc.ac.in. So this brings me to the end of the first session, the introduction to the workshop. We'll move to the next session, but before that, I'm ready to take questions if you have any. All right. So give me a moment. I think there are 34 members already. I think the recording is also going fine. All right. So let's jump into the first technical session of the day.